Hi, my name is John.
And my name is Alice, and this video is for parents who are trying to help their kids with math. So let's talk about multiplying integers. The way I learned it when I went to school was the standard algorithm. So I'm going to do it that way first. Then John's going to show us the partial product method, which is probably how your kids are learning it. And then I'll do another problem that way. So the way I learned it was I'll do 6 times 3, which is 18. Then I do 6 times 4 is 24 plus 1, which is 25. Then I start with a 0 here. And 5 times 3 is 15. So keep my 1 up there. 5 times 4 is 20, plus 1 is 21. I'm going to add these up. That's 4. And that's 2. So I get 2,408.
Great job, Alice. In today's elementary school classrooms, the method of choice is the partial product method, and this method stresses the conceptual aspect of multiplication and breaks up the tasks into smaller tasks where students find exactly what the title says, partial products. They break the numbers up into easier numbers whose products they could find, and then they add them all up at the end. So the way to do the partial product method is to rethink of 43 as 40 and 3, 40 plus 3, and 56 as 50 plus 6. And we chose to use multiples of 10 because students learn how to count multiples of 10 from a very young age. This is very familiar to them. We create a visual representation of this by drawing out a rectangle, and we break it up into smaller rectangles where students can keep track of their answers. So the first thing we would do is 50 times 40 to get the area of this first rectangle, and most students can do that in their heads. They know that 5 times 4 is 20, and then they throw the 2 zeros on at the end. They next could do 50 times 3, that's 150, and would give us the area of that rectangle. For the bottom left, students can do 40 times 6. That is 240. Again, that's easy for them to do because they know 6 times 4 is 24, and then they can just add the 0 on the end. And then the last box here is the easiest one, 6 times 3, which is 18. By doing it this way, students are now dealing with 4 partial products, 2,150, 240, and 18. So now they can add up each of these partial products into a grand total. And what most students like to do is they like to group quantities together to make the adding a little bit easier. So the students might take something like 150 and 240 and make that 390 because that's a little bit easier to add, and it reduces the number of steps they have to take on paper. And then what they would now need to do is just add up 2,000, 390, and 18. They would know 390 plus 18 is 408, and then 2,000 plus 408 is 2,408. You might be wondering, why would they do all this when they could just use Alice's approach, which seems to be a little bit more direct and have a little bit less writing. But as students move up in their mathematics careers, they will be multiplying binomials by the time they get to high school, which contain variables. And by getting used to this area model partial product approach, it makes the harder math later on a little bit easier for them to understand and a basis for their understanding when they get to more complicated mathematical ideas.
Okay, so let's try another problem. We're going to try 43 times 12. So based on the method John just showed me, I'm going to break this up into 40 and 3 and 10 and 2. I'm going to draw my rectangles. And this is going to help me remember what I'm actually solving for here is the area. So this is going to be 40 times 10, which I can do in my head is 400. 40 times 2, which I can do in my head is 80. 10 times 3, which I can write down as 30. And 2 times 3, which is 6. So now I just need to add up everything. So I'm going to write them all down. But John, obviously I could in my head say add up 40 and 80. Would they, are they encouraged to show all their work, or would it have been okay if I had already kind of added those together in my head?
We do encourage mental math
Okay.
where possible. If they're able to add 80 and 30, that's totally fine.
Okay, so I could have written it out like this, or I could have thought, well, I know, for example, I know 480. That's very easy to do in your head. And then this would have been 36. So that would have been fine to just show that.
Yep.
Okay, great. So I get 516.
Great work. And it's funny because partial product sounds like a scary title, but when you actually break it apart, it's really nothing less than dividing a larger task into four smaller tasks, which are more manageable for a student to do in his or her head. And then you get the result by adding them all up.
What I really like is that this mental math is quite easy to do in your head. And also, I like the rectangles because it kind of reinforces why we're doing what we're doing. The way I had shown it, for example, when I did the second line, I start with a 0. And as a child, I didn't know why I was doing that. I just memorized to do it. But this way, it's I think it's more intuitive, actually, once you learn how to do it this way.
Agree. And when I was a child, we didn't even use zeros. We used X's as placeholders. So that was like so random to us. Like, why are we using an X in the middle of a multiplication problem? And then when you go into middle and high school, X means something totally different. So I think this is, more conceptually coherent across the grade levels.
Great. Wonderful. Well, thank you, John. This was really helpful.
All right. Thank you. And hopefully, you guys can check out some more of our videos as we post them. And we look forward to doing some more math with you. Take care.